Good morning, my dear students. Welcome to this digital chemistry class. And as you know that we are doing our unit 9, that is coordination compound. And today we are going to again introduce the coordination compound in different way. So dear students, before going to proceed to this topic, let me appeal from you. Let me again remind you that your first term exam or terminal SA1 exam is going to be start very soon. So for that purpose, as we have started our recycle revision process, in which yesterday I have given you the homework of unit 1 from that assignment which I have already shared. Now I wish that today in the same routine you will do chapter 2 and tomorrow, which is 15th August also. So very happy Independence Day to all of you in advance. And tomorrow I wish that you will do unit 3 yourself. Then on Sunday you will take your own test by making your own question paper like last year you were doing. That is of unit 1, unit 2 and unit 3. And on Monday all of you will send me your test report or answer sheet photograph that you have taken from your own question paper, okay? Or it will be like this way, okay? I'm going to give one work to all the group leaders. Those group leaders are there. They will make a question paper, single question paper, and they will share the question paper to all the group members. And after that, the group members will solve that question paper within of 2 minute or 2 hour or 3 hour paper by themselves, anytime, morning, evening, afternoon, whenever you feel. And on Monday you will send me the report of your answer, and the group leader will give me the report, okay? And I would be not available for Monday, so but that is your assignment. This you have to finish, and on Monday you do the chapter number 4. So in this way, up to Tuesday your first to fourth chapter will finish, and on Tuesday the test would be from first to fourth chapter, and the test would be of 30 marks, okay? 30 minute 30 marks test. So we ready? And let's start today's topic. Dear student, let's start today's topic with positive mindset. It is that what is written here: success is the sum of small effort. Sum is mean addition. So success is the sum of small effort repeated day in day out. So as I said, if revision we are doing, so day by day whatever chapter you are studying, that will be the repeated process in a day to day out, and this effort will definitely give you the success in your upcoming exam, okay? So this is unit 9 we are doing. Total marks 3 it will in exam it will come, whereas coordination compound or complex compound is the name of the chapter. So from where the complex compound came or complex compound worth occur, that is very important. That is from D block and F block. Already we have studied D block and F block. We know D block containing all the important metals, which is earth rare metals, which is known as transition metals, because each metals are easily transforming its electron to other, and it can form compound with each other, which is called alloy. And because of that, the complex compound can be formed, okay? So the transition metals form a large number of complex compound in which the metal atom are bound to a number of anion and neutral molecules. So once again, transition metals, D block elements, form a large number of complex compound in which metal atom are bounded with the number of anion or neutral molecule. So these are the meaning. In modern terminology, such compound are called coordination compound. Like chlorophyll, hemoglobin are coordination compound. Chlorophyll is the coordination compound of magnesium, and hemoglobin is the coordination compound of iron. Variety of metallurgy processes, industrial, catalytic and analytic reagent involve the use of coordination compound. Whereas coordination compound also find many applications in electroplating, textile dyeing and medicinal chemistry, okay? So all these things we are going to study in this chapter. So let's recapitulate as yesterday's video I made, that is Warner's theory. Warner was the first scientist in 1898. He propounded in his theory about the coordination compound. The main postulates were: in coordination compound, metals show two types of linkage, that is valencies, primary valency and secondary valency, in which primary valency are normally ionized and are satisfied by negatively ion. Secondary valency are non-ionizable. These are satisfied by neutral molecule or negative ions. The secondary valency is equal to the coordination number and is fixed for a metal. The ion group bound by secondary linkage to the metal have characteristic special arrangement which is corresponding to different coordination number. Basically, in modern formulation, such special arrangement are called coordination polyhedra. The species within the square bracket are coordination entity. हमेशा आपको you know very well the coordination compound is written inside the square bracket, and which is whatever is written in the square bracket, and where one central metal is there with that primary valence is there, then with that secondary valence is there. Okay, and somewhere we saw that with metal or primary valency there is positively charged, that these all are called coordination entity or complex, and the ion outside the bracket are called counter ion. Got my point? So once again, all the compound which is present inside this bracket, that is metal, primary valency, it can be secondary valency here, then the positive charge. So it means that this is called coordination complex, this is called central metal, this is called primary valency which is ionizable, this is called secondary valency which is non-ionizable, this is called counter ion. So these are the basic terms that we are using, and after this the definition, some of the definitions that we have done, this is also we have done in recapitulation. First is coordination entity. The coordination constituent of a central atom or ion bound to a fixed number of ion and molecule. For example, this is called coordination entity, in which central atom, F is suppose central atom or my ion. In the coordination entity, the atom ion to which a fixed number of ion and group are bound in a definite geometry arrangement, which is called central atom or ion. Whereas coordination number, we will talk the coordination number of metal ion as complex. It can be defined as a number of ligand donor atom in which the metal is directly bonded. Whereas coordination sphere is the coordination central atom or ion and the ligand attached to it are enclosed in the square bracket and is collectively termed as coordination sphere. The ionizable group are written outside the bracket and it is called counter ion. Next, if we will talk about the ligand, which is very important. Ligand, the ion, these are the ion and molecule bound to the central atom, which is bounded to the central atom in the coordination entity, which is called ligand. These may be simple ions, small molecule, large molecule, or macromolecules. If we will talk about classification, it can be single, two, or many. Monodentate, single ligand is called monodentate. Suppose H2O, Cn negative, NH3, NO2. These all are monodentate. Example of monodentate. So here example you can say with covert mine is there, 3 positive, 3 positive. So this is monodentate example. And bidentate oxalate ion C2H04 ethylene diamine. These are the example of or orthophenanthroline is bidentate, example of bidentate. And polydentate is called chelating agent, mean it is making a web. Web mean एक जाल की तरह बनाते हैं ये मेटल के चारों ओर, that's why it is called chelating. So two or more donor atom is present, so it is called polydentate. EDTA is the example. This is the formula, and this is all about the ligand and its classification. After this, there are some definition. Oxidation number of central atom. The oxidation number of central atom is a complex which is defined as the charge it would carry if all the ligands are removed along with the electron pair. It means that is shared with the central atom. It will carry some charges. That is called oxidation number. Homoleptic, heteroleptic complex. Two type of complexes are there, homoleptic and heteroleptic. Homoleptic complexes are there where in the central metal which is bound to only one kind of donor group, and complex in which a metal is bound to more than one kind of donor group are called heteroleptic. Whereas coordination polyhedron, the special arrangement of the ligand, special shape of the ligand around the central metal which is directly attached to central atom are defined as coordination polyhedron. The most common coordination polyhedron are octahedral or square planar, and square tetrahedral plus square planar can make octahedral. Okay, so this is all about, and what are the reason basically to form this such large complex by a d block element, that is orbital occupancy. मतलब ऑर्बिटल में इतनी खाली जगह है कि इलेक्ट्रॉन कैन बी शेयर एंड it can make these kind number of, these are unpaired electron, so this much number of bond it can form. So because of that there has tendency, probability to form large complexes. Because of that lanthanide series form coordination compound. There are reason why coordination compound are colored also, because it has electrons in partially filled d or subshell which absorbs visible light and moves to slightly higher energy to d orbital. That is called magnetic property also, which is due to unpaired electron. Then if we will talk about coordination compound, so it consists of a complex sign. Basically complex sign, it is forming a complex sign, एक अलग तरह complex sign है, and which has necessary counter ions. Suppose this is complex sign now, and in which these two positive Okay, this is complex sign which is present inside the bracket, in which NH3 is primary valency, Cl is secondary valency. Okay, and carbonate, you can see cobalt is 3 positive, in which 5 amine is attached as a ligand, primary ligand, whereas if we will talk about the this oxidation number of ammonia, it is 0. Valency of ammonia is 0, amine is 0, and valency of chlorine is -1. Okay, secondary valency have always that valency which is actual valency, but the primary valency is somewhere that we need to learn. So after that, when we are calculating its oxidation number, it will come +2. Okay, it means that +2 is the oxidation number of this counter ion. Okay, that's a complex sign. That's why there are 2 chlorine to balance this oxidation number. So counter ion is outside the bracket. Okay, so if we talk coordination chemistry, transition metal act as a Lewis acid, which form complex ion, and in which transition metals are basically metals, and the which is ligands, that is basically Lewis base. Okay, so complex contains central metal atom which is bounded one or more molecule or anion. So Lewis acid, central metal is called Lewis acid, which is center of the coordination, and ligand are called Lewis base, which is surrounded the metal atom. So central metal plus ligand plus valency, central metal plus ligand plus valency will form a component of coordination compound. For example, this is a formula in which inside this bracket this is called coordination complex, and the chlorine 3, this is called counter ion. Okay, and if we will make this diagram structure, you can see when we are going to in solid, the stress crystal is like this, compound is like this. When we are going to hydrolyze this in water, somewhere the 3 positive complex ion and bromine 2 or chlorine 3 ion will counter mean it will attack in the central metal and satisfy the coordinating valencies. So complex ion remain intact upon dissolution of water also. That is the main thing. So information between complex ion and ligand. Basically complex ion, these are the species where transition metal ion is surrounded by a central number of ligand, where transition metal ion is Lewis acid and ligand is Lewis base. Okay, this we have already done, and this is the way how to write the coordination complex. If we will talk about ligand, molecule or ion which have lone electron pair that can be used to form the bond, and Lewis base is coordination covalent bond in which metal and ligand will react. There are monodentate, bidentate, polydentate, 3 type of ligand. Now we will talk about the types of ligand. It is already we have done. It is unidentate, bidentate, polydentate in detail with examples. So pause this video and just take screenshot and do note down these ligand in coordination compound which is given. What is unidentate, bidentate, polydentate, how to write, because it is very important to learn, because in future we are going to write the complex sign. Now geometry of complex sign, if we will say, so if the complex sign have coordination number 2, shape will be linear. This will be the diagram, and these are the example. 4 square planar, 4 again tetrahedral, okay, and 6 octahedral. So basically we have these in this particular chapter, okay, that we need to study. So if nomenclature, now which is very important, nomenclature, how to write the coordination compound. Dear students, these are the steps. First, how to write the formula of mononuclear coordination. The central atom is listed first. Central atom is listed first. The ligand are then listed in alphabetically order. सबसे पहले सेंट्रल मेटल का नाम लिखेंगे, फिर the ligand are then listed in alphabetic order. Yes, if suppose chloro is there or amine is there, the amine will be written in front of chloro because A is coming alphabetically before C. Got my point, I think. The placement of ligand in the list doesn't depend on its charges. Okay, mean it should be on the basis of alphabety, not on the basis of charges. Polydentate ligand are also listed alphabetically. This is the third rule. The formula for the entire coordination entity is enclosed in a square bracket. That is also the rule. When ligand are polyatomic, their formula are enclosed in parentheses. Ligand abbreviation, parentheses mean like this way. Ligand abbreviation are also enclosed in parentheses. There should be no space between ligand and metal within a coordination sphere. When the formula of a charged coordination entity is to be written without a contra-ion, the charge is indicated outside the square bracket as a written right superscription with the number of before the sign. Yes, suppose we are writing here 2 plus 3 plus, that will be written here. The charge of cation is balanced by the charge of anion. So now second, formula of mononuclear coordination compound, the cation is named first. in both positively and negatively charged coordination entity. Cation is named first. पहले cation का नाम लिखेंगे जो cation होगा. First in both the positive and negatively charged coordination entity. The ligand are named in an alphabetical order before the name of central atom. अगर कोई जैसे suppose we have cobalt ऐसा like this. Then here if suppose we have any positively charged cation, that will be written first. Potassium, hexaamine, suppose hexaamine, copper, then its oxidation number, chloride. This is the right way. Name of the anionic ligand end in. This is very important also. Name of the anionic ligand end in O, like chlorido. Those of neutral and cationic ligand are same except aqua, because aqua is not aquo. Okay, amine is amide, carbonyl, nitrosyl for NO. This is the placed within enclosed mark bracket. Prefix mono, di, tri are used to indicate the number of individual ligand in the coordination entity. When the name of the ligand include numerical prefix, then the term used bis, tris, tetrakis, bis for 2, tris for 3, tetras for 4, like this way, and the ligand to which they refer being placed in the parenthesis. If we will talk about oxidation state of a metal in cation, anion and neutral coordinate entity, it is indicated by Roman numerical, like this way, 1, oxidation number of 1. If any molecule oxidation number is 2, so like this way. If the complex sign in cation and metal named same as an element, if the complex in an anion, the name of the metal end with the prefix 8, like ferret. Okay, if the complex sign of a जैसे cation और element का same नाम है, तो जो कॉम्प्लेक्स में जो मेटल है उसका नाम हम 8 से ख़त्म करेंगे. फेरेट, कार्बोलेट, कोबाल्टेट जैसे. फॉर सम मेटल द लैटिन नेम इज यूज्ड लाइक फेरेट फॉर Fe. द न्यूट्रल कॉम्प्लेक्स मॉलिक्यूल is name similar to the complex cation. So these are the basic rules. Now if I talk about the formula, first cation we will write, then anion. Total charge must balance to 0. Complex ion will written in bracket. Suppose this is an example. Now what is the metal ion? This is potassium. So I will write potassium first. Potassium. Then inside the bracket there is 2 amine or 4 chloride. Then I will write diamine, potassium diamine, cobalt. Then in bracket we will write its oxidation number, chlorido we will write here. Okay. Similar way, tetraamine. Here there is no potassium ion. You can see there is no positive charge, as here it was K. So direct we will start from amine, primary valency, tetraamine, tetraamine cobalt. Then tetraamine cobalt के बाद हम oxidation number लिखेंगे. Then chloride, dichloride, नहीं tetraamine dichlorido, cobaltate, chloride. Okay, this is the name. Cation, then anion is the first, ligand is the second. In alphabetically word we have to write ligand. For neutral word molecule name we will write. For anionic we will use ide to O, ido. Then prefix indicate number like bis, tris if there is there. Oxidation state we will write inside the bracket, like in this bracket, in the Roman way. And complex ion will be anion or metal ending with 8. These are the basic rules, and I think you got. Now dear students, do practice. These are some of the nomenclature rule, like it will help you. Suppose all these are neutral ligands. If H2O is there, you will write aqua. If NH3 is there, you will write amine. If CO is there, you will write carbonyl. If NO is there, you will write nitrosyl. These are anionic ligand. Fluoro for F negative, chloro for Cl negative, bromo for Br negative, iodo for I negative, hydroxo for OH negative, cyano for Cn. Okay. And if we will talk about metal ion, iron is a ferret, copper is cuprate, lead is plummet, silver is argentate, gold is orate, and tin is titanate. These are the basic exceptional Latin word name. Okay. So now next is how to name. So there is one example like K2. As I said, first we will write K2, potassium. Then we will write primary valency, diamine. Then we will write chlorine if it is inside the bracket, tetrachloro, cobaltate. And if it is cobaltate, how to calculate this oxidation number, that is also you need to learn. So see, K oxidation number is +1. Multiply by 2, it is 2. Then cobaltate, we are finding oxidation number X. Then NH3 is 0, so it will remain 0. Chlorine is -1, so it will become -4. So the total oxidation number become 2 plus x plus 0 minus 4. So it will be x is equal to minus plus 4 minus 2, x will be 2. Okay, that's why there is 2. So like this way you will find out oxidation number of any compound. Next is this. So again there is no counter cation, so we will write simple tetraamine dichlorocobalt, then this is oxidation number and chloride. Okay, like this way dear students, I am sending you some of the question. You need to write the name of this example. Okay, so hope so you understood today what we did. We did again the introduction of coordination compound, from where we started. Let me take, this is introduction, this is recapitulation of Warner's theory, this is we did important definitions, this is we did ligand and its type, this we did polyhedron and homoleptic heteroleptic, then this we did why the reason is there for large complex, why the reason is color compound, what is coordination compound, what is coordination chemistry, then we did here complex compound, then we have done here the basic component of coordination compound, then we learned about the complex ion and ligand, then we understood the basic again different type of coordination number and shapes, then we started nomenclature rules. These two are very important. You just take screenshot and learn the numerical nomenclature, try to understand. And this is the how to write the formula, what is the sequence, and what are the basic name of the ligands and metal. Then this is the example. Now hope so you understood everything. Thanks for watching this video, and whatever instruction I have given in the beginning, please do follow that. Okay, so have a nice day. Once again in advance, happy Independence Day to all of you. Thank you.